Hello, this is Michael L. Perry. Welcome to my course, EF Core 6 Best Practices. I'm a Director of Consulting at Improving and a software mathematician. EF Core 6 builds upon new language features and capabilities in .NET 6 to give you productive, safe, and performant components for data access. There are many different ways to construct an application from those pieces, and in this course, we're going to examine those options so that you can identify the ones that work best for you and your team. Some of the areas we'll explore are layered architecture, automated testing, security, continuous deployment, and performance. By the end of this course, you'll know how to select the best patterns for building, testing, and deploying data-centric solutions. Before you begin, be sure that you have a solid understanding of C# 10, .NET 6, and EF Core. Other courses in this path, such as Julie Lerman's EF Core 6 Fundamentals, will give you a good foundation. Every app is different, and only you can decide what's best. So let's get started making the most of Entity Framework with EF Core 6 Best Practices at Pluralsight. Hello, and welcome to EF Core 6 Best Practices. I'm Michael L. Perry, software mathematician. I'll be your guide through the Entity Framework landscape. We'll start by structuring your project for cleanliness and testability. In this course, we focus specifically on Entity Framework Core 6. This version of Entity Framework requires .NET 6. We'll be taking advantage of the latest Visual Studio and C# language features, and we'll be testing and integrating our code using Docker. EF Core 6 and .NET 6 are long-term support versions, meaning that you can expect a 3-year lifespan from Microsoft. Docker is constantly evolving, so check to make sure that your tools are up to date. This course does not apply to earlier versions of Entity Framework. In particular, be careful not to confuse EF Core 6 with EF6. Entity Framework 6 was built for the .NET Framework 4.5 through 4.8, and it predates EF Core. It's an entirely different runtime. This course also does not apply to earlier versions of .NET. It specifically takes advantage of language and runtime features added in .NET 6. Now that you're tooled up, let's meet Carlos. A successful solution starts with a good project structure. Let's see how he kicks things off. Carlos is the lead developer on the new GlobalTicket Promotion API. This is the backend for their new suite of mobile and web applications, as well as all future partner integrations. It's the centerpiece of GlobalTicket's new product line, and Carlos is just the right person to lead the effort. He's eager to dive in and get started coding. He wants to create a new ASP.NET Web API project, add Entity Framework Core 6, and develop his model code first. But then he stops to consider all of the things that he will need to do in order to make this project successful. He'll need to automate the build process, and he'll have to gradually evolve the schema. Will he be able to distribute database migrations with continuous deployment if everything is jumbled together? He doesn't think so. And what about security? He wants to strictly control what the application can do. After all, if a process is compromised, he'll need to limit its access to control the damage. And then there's testing. Can the business logic be unit tested if it's tightly coupled to the data storage? And on the other hand, can the tests be trusted if they don't hit the database? On top of all that, how can his team iterate quickly if they have to wait for slow data-centric tests? And so he decides he needs to take a step back and plan the solution carefully. It should address each of these concerns. It should have seams in just the right places so that different parts can be composed and tested appropriately. But it should not be so complex that it slows down the team or confuses new developers. This is going to take some planning. There are a lot of variables to consider when planning a project. Chief among them are the entities and their relationships to one another. And we also need to be sure not to allow bad data into our system, and we need to evolve that data schema over time. But we also need to keep the data secure, and that also means authenticating users and authorizing their access to the system. Of course, we need to represent that data to the user, and when they ask for it, they need paging, sorting, and filtering options, not to mention aggregating data for greater insight. We'll need to add some visibility through logging and consistency through governance. Oh yes, and we'll need to integrate this product with everything else in the company. That's a lot to think about. So, to better organize these concerns, Carlos decides to group them. Decisions that change together stay together, and things that vary independently go into different layers. For this, Carlos takes inspiration from Steve Smith's Clean Architecture template. That template defines 4 project layers within a solution. At the bottommost layer, Carlos places cross-cutting concerns that have nothing to do with the problem space. This forms a shared kernel that any application could use. And then he builds in knowledge of the domain. At this layer, we know what problem we're trying to solve, but we haven't locked ourselves into any particular technology decisions. The technology decisions come in at the infrastructure layer. This is where we choose how to map the domain into a storage engine. And then finally, the presentation layer implements our API. This takes on all of the concerns related to how consumers will access the system. Carlos is a big fan of clean architecture, and so he considers architectural patterns as they've evolved over time. One early pattern was the data access layer. This pattern puts an adapter in between the business logic and the database. On the surface, this makes sense, but Carlos has seen problems that arise from this style of project. In his experience, the data access layer ends up doing all of the work. Knowledge of the problem domain ends up embedded within the records, and the business logic leaks into the queries. With the data access layer taking on all of this domain knowledge, the business layer ends up being a redundant pass-through, just mapping from one object structure to another very similar looking object structure one level down. This architecture puts the knowledge in the wrong place. Then he remembers the repository pattern from domain-driven design. It aims to keep the knowledge in the domain where it belongs. Domain services act upon a repository which abstracts away knowledge of the storage provider. That leaves the services nice and clean while focusing on their intended role. Now he just needs to decide how to implement the repository pattern.